All right, folks. There is dark matter, and then there is dark energy. They are not the same thing, not even close. But the word dark in both of these is a indicator of the lack of understanding that we humans have for both of these ideas. Maybe when you are old people and grandparents, your children will call these different things. But right now, we are referring to them as dark matter and dark energy. Dark energy is a newer idea. Late 1990s, early 2000s, with Alan Guth and his colleagues discovering the fact that the universe was accelerating, there was something that was stepping on the gas pedal. There was something that was making the universe accelerate away from each other. Galaxies were flying apart faster today than they had been in the past. To explain that, they coined the idea dark energy. Now, what is dark energy? It's a form of energy. So when we say energy, there's lots of different kinds. There's heat, there's light, there's radio waves. Sound is a form of energy. There's energy of motion, like kinetic energy, energy of position, like a rock on the roof is more dangerous than a rock that has already hit you. There's nuclear energy. There's so many different kinds of energy. And dark energy is one of these forms. It permeates all of space. So that means that it is between you and your computer screen right now. It is between, if you open your mouth, there's some in your mouth. Yeah, in your mouth. There's actually dark energy in there. It's everywhere. And this thing is accelerating and causing the expansion of the universe. Now the challenge is, it's kind of a repulsive force. It adds speed, it adds kinetic energy to the universe. It actually is making it accelerate outward. It's kind of like if the universe was a balloon, it's speeding up the rate at which that balloon is blowing up. Dark energy also makes up vast majority of the total energy and matter of the universe. So it is a big thing. This slide is very important because these two things are odd, and I want to make sure you understand the difference between the two. Dark energy is repulsive. It is the thing that is making galaxies accelerate away from each other. It adds speed and kinetic energy to the universe, and it causes galaxies to accelerate that rate of expansion. And where do we find it? Absolutely everywhere. It makes up over or around 70% of the entire universe. Now, dark matter is opposite. Dark matter is attractive. Dark matter actually produces a force of gravity. Galaxies were found to form along areas of high amounts of dark matter on the cosmic web. On that cosmic web, those were areas where dark matter has a tendency to cluster. What is it? We think it is a combination of WIMPs, weakly interactive massive particles, and MACHOs, massive compact halo objects. Dark matter also can be found everywhere, makes up about 25% of the universe. Both of these are still in the we don't know much stage, and within the next handful of years we will learn more. So what actually is this dark energy? There's a couple different possibilities. One, it is a property of space itself. Space-time that we always call a fabric, it has certain properties. It behaves in certain ways. This could just be Einstein's cosmologic constant, meaning it is a number that gets thrown into the equations to make the equations work. And it describes what actually is happening in nature. It is just a property of how nature behaves for space and time. Whatever it is, it's very homogeneous, meaning it's the same everywhere, kind of like homogenized milk. Homogenized milk, the butterfat's all moved in, is all evenly distributed. Homogeneous, meaning every bit of the universe is pretty much like the next bit. It could also be due to particles appearing and disappearing out of this quantum or space-time foam. So it could also have to do with that matter appearing out of energy and energy falling back when the matter dissipates. One of the other hypotheses about what dark energy is it could be some sort of an energy field. Very much like if you have a magnet, there is a magnetic field around that magnet. And we didn't know about those magnetic fields really until a few hundred years ago. Maybe there is some sort of energy field that fills all of space, kind of like a fog, totally encompassing a whole campus or a whole neighborhood. It could be this weird cosmic fog, whatever it is, drives cosmic expansion, making things get bigger and further apart. This fog or this dark energy has varied over time. We know that because of the fact that the universe has expanded and its rate of expansion is accelerating. But recent evidence don't support this totally, this quintessence or space-filled fog. The bottom line is we don't totally know what dark energy is. It is a front runner in the field of physics right now. So how will the universe end? Well, there's a couple different options. If you've ever studied any geology, there are different geologic periods. Tertiary, Cretaceous, Jurassic, all of those different ones. Astronomers have created different eras in astronomy. And right now we're in the stellariferous era. Stellar, meaning shiny lights of stars era. Lots of stars. And it's hypothesized that life in the universe is going to stop in about 10 to the 15th years. That's a long time in the future. Do not lay awake nights worrying about that. That's a long way off. When all the stars start to go out, the next era they are predicting is called the Degenerate era. And that's when the stars start to stop shining. Objects get thrown out of galaxies or they get swallowed by black holes. And that's going to be about 10 to the 30 years from now. After the Degenerate era will be the black hole era. And it is hypothesized that the last things that will exist in the universe are black holes. They're going to gobble up everything around them. And maybe, if Hawking radiation is real and can be proven, even the black holes will start to evaporate. And that is in about 10 to the 100th years. And then lastly, we think the universe is going to end in a big, dark, cold whimper. Very few photons of light will be left. They will all be absorbed. And then all this energy will be spewed across this huge, huge universe. And it will be cold and dark and lifeless. Not terribly happy ending, but it's a long way off. So how will it all end? It all depends upon, this is what scientists think at the moment, how much matter there is. Because matter is going to determine gravity. And that will determine if we have that open, closed, or flat universe. How much normal matter is out there. And how good are we at measuring it? How much dark matter is out there. And how much dark energy is out there. These are the questions astronomers are working on right now. The answers, don't know what they're exactly going to be. But that's why we do science, because we don't know everything yet. I'm going to ask you to watch a little video talking about dark matter and dark energy, and we will see you later. That will end this topic. Bye-bye.